Okay, we're looking at the first quarter fun review sheet. We're going to do 1 through 5 in this section. Number 1, they tell you that a 4-kilogram object is accelerated 3 meters per second squared north by an unbalanced force. Let's find that unbalanced force. F net is equal to m times a. The F net is the same thing as the unbalanced force, net force. The mass is 4 kilograms. The acceleration is 3 meters per second squared. That gives us a net force of 12 newtons. Part 2 of the question, the same unbalanced force will give me what acceleration for the other object? F net over m. I have 12 newtons divided by the new mass, which is 2 kilograms. And I get an acceleration of 6 meters per second squared, which is choice B. Number 2. Okay, a student standing in an elevator experiences 2 forces. The student experiences gravitational force exerted by Woofie and a normal force exerted by the floor of the elevator. These are the 2 forces referred to in this problem. We're also told that the student is accelerating downward. That means the forces are not in balance, but the forces are unbalanced, and the gravitational force is the bigger magnitude because you're accelerating down. Okay, if I were to make up numbers, if the gravitational force is, let's say, 800 newtons, that means the normal force has to be some smaller value, let's say 700 newtons. All right. In the question, they say the force that the student exerts on the floor of the elevator must be. They're referring to the normal force, the force between the student's feet and the floor. That's 700 newtons. And then they compare it, and we're going to go through these one at a time. They say, first of all, is it less than the weight of the student when at rest? I don't care if the student's at rest, if the student's running a marathon, or if the student's riding in an elevator. This student weighs 800 newtons. So choice A is correct because the 700 newton normal force is less than the weight of the student when at rest. Let's just check the rest of them. Greater than when the weight of the student is at rest. B, no, we've already established that the normal force has to be smaller because the unbalanced force is down. C, less than the force of the floor on the student. That's the exact same force as the force of the student on the floor, because that is the force between the student's feet and the floor. That's going to be 700 newtons as well. Choice C is also 700 newtons. Choice D is also 700 newtons, so it's saying greater than the force of the floor on the student. No, they're the same. So C and D are both wrong. We're left with choice A, which makes us very happy. Moving on, number 3. Give me room. 3. Okay, 2 forces applied on the block, and I'm not going to draw this. We have a net force to the left of 10 newtons, F net. To the left is 10 newtons because we have 12 newtons to the left and 2 newtons to the right. They tell me also that the magnitude of the block acceleration is 2 meters per second squared. What's the mass of the block? M is F net over A, substituting the equation for M, and I get 10 newtons divided by 2 meters per second squared, 5 kilograms. That would be choice B. Okay, 4, new color. Basically the same as the last one. I've got a 25 newton horizontal force north, 25 newtons north, and I've got 35 newtons south. That gives me a net force of 10 newtons south. It has a mass of 15 kilograms. What's the acceleration? A equals F net over mass, 10 newtons divided by 15. So 15 kilograms gives me 0.67 meter per second squared. It's south, but they don't care because they only asked me for the magnitude, and that is choice A. Finally, number 5. Okay. Strength scale is exerting a 20 newton force on a mass across the table. Trick question here. Here's the mass. Here's the spring scale with a little hook. There's a little string on there. They're asking about the force between the spring scale and the block. If the spring scale is exerting a 20 newton force on the block is exerting a 20 newton force on the spring scale, because this is one force, one interaction between the block and the scale. Same damn force.